Alright, what's up guys? In this video we're going to pick up some vector calculus here, and we're going to be talking about two-dimensional curl, two-dimensional divergence. So we're asked to assume C is a circle centered at the origin, oriented counterclockwise, that encloses the disk R in the plane. They want us to complete the following steps for the given vector field. They give us the vector field here F, and they want us to calculate the two-dimensional curl of F, calculate the two-dimensional divergence of F, and determine if F is irrotational on R and if it's source-free on R. So basically 4 parts to this, and we'll start with part A. So the first thing that we need to do is get the definition or the formula for the two-dimensional curl. So for the 2D curl of F. Okay. So recall if I got some vector field, let's say, I don't know, F comma G, for example, and I want to find the two-dimensional curl. Well, it's just going to be the partial of G with respect to X minus the partial of F with respect to Y. Or it may be written as the partial of G with respect to X, I, minus the partial of F with respect to Yj. So that's how I get the two-dimensional curl. So let's get that out of the way. So I need to get the curl of F here. So that's just going to be the partial with respect to X for 2Y. It's going to be subtract the partial with respect to Y for 7X. Okay. Now clearly the curl here is 0. So we end up getting 0 as the curl. Okay. So that takes care of part A. That's the curl. So we could say final answer for part A. Say that the curl is 0. So that takes care of part A. Now what about part B? We'll do that next. And there's a reason why we need to compute these first, because that's how we're going to get the answer to C and D. So let's go ahead and do the next one. So now part B, they want the two-dimensional divergence. That's what they want for that. Okay. So recall that the two-dimensional divergence, okay, remember that's just going to be the partial of F with respect to X plus the partial of G with respect to Y, or again, it may be written as DIF is equal to the partial of F with respect to XI plus the partial of G with respect to Yj. So it may be written that way. That's the two-dimensional divergence. Okay, so let's get that out of the way. So we'll have the IV. And so what we're going to end up having is the partial with respect to X for 7X plus the partial with respect to Y for 2Y. And we see what we get here. So this clearly just ends up giving me 7 plus 2, which is 9. So our two-dimensional divergence is going to be 9. So that's the final answer for part B. So let me circle that. Now, part C and D, we don't actually have to do any work for, because part C says, determine if F, which is our vector field, is what we call irrotational on R, which is the region. Okay, so is it irrotational? So remember, in order for a vector field, in this particular case that we were given, to be irrotational on R, that basically means that the curl of that vector field needs to be equal to 0. So if we go back to problem, or we go back to part 1, when we calculated the two-dimensional curl of F, recall that we ended up getting the curl to be 0 for part A. So if the curl is 0, then that means that that means that the vector field F is in fact going to be irrotational on R. So we can say that yes, F is irrotational on R, and R here is the region. So that's part C. So that's part C right there. And again, two-dimensional curl was equal to 0, so it's irrotational on that region. Now part D was determine basically was determine if F is source free on R, which is of course the region. Okay, so remember, for our vector field F to be source free on R, which again is the region, the two-dimensional divergence needs to be equal to 0. Now when we calculated the two-dimensional divergence of the vector field, we ended up getting 9. So since the two-dimensional divergence of this vector field was not 0, this vector field here is not source free. So we can say that F, which again is the vector field, is not source free. And that again is because the am I spelling source right? Yeah, source. Free, because the two-dimensional divergence was not equal to 0. So it's not source free on that region R. Okay? And that's your final answer for part D. So that essentially takes care of all parts of the question. So let me know if you have any questions. I'll be more than happy to talk about it. So see you next time.